Good afternoon. I am Pramod Kumar Srivastava, Professor, TMIT, TMU. My subject is Business Research Methodology. In Business Research Methodology, today I am going to discuss on classifications. So, there are different type of classification in this topic classification. Just we are classifying data in a different format. We are also going on it. So, the table of content is the meaning, classification, objective, method and classification, classification according to the attribute, classification according to variables, term relation to the frequency distributions, formation of the different frequency distribution, data array, steps to be conducting a frequency and guide for the selecting the classifications. So, learning objectives or the learning outcomes. After this unit, you should be able to understand the meaning of the classification, state the objectives and the method of the classification, describe the various methods of the classifications and related to the frequency distribution and construct the frequency distributions. So, frequency distribution, when observation whether they are discrete or the continuous available on a single characteristics of the large number of individuals is become necessary to condense the data as far as possible without losing any information on interest. Let us consider the age of 30 students selecting the random from among those studied in the certain classes. So, here there is a list of 30 students, that list is given in this slide. So, there is a list is 20, 22, 25, 20, 21, 22, 25, 24, 23, 22, 21, 20, 21, 22, 23, 25, 23, 24, 22, 24, 21, 20, 23, 21, 20, 21, 20, 21, 22, 25. So, simply there is in the list of the 30 students and their age is given in this data. So, how we are finding the frequency distribution? This present the data is not considered as in the good sign for the larger number of the observation. It is not necessary to handle the data in the form of better way to express the figure is shown in the table. So, simply there is the 30 student according to their age. So, first we divided data on student age group. So, there are the certain common number of their age group is 20, 21, 22, 23, 24, 25. So, student from the 20 age group is the 4 student, a student from 21 age group is the 7 student, a student from the 22 age group is the 8 student, a student from the 23 age group is 4 student, a student from 24 age group is 3 student, or a student from 25 age group is the 4 student. So, this is the total 30 student and the frequency of these student is 4 frequency of the 20 age group, 7 frequency of the 21 age group, 8 frequency is the 22 age group, 4 frequency is the 23 age group and 25 frequency is the 4 age group. So, total 30 frequency. So, by this way the presentation of data is considered as in the good sign of the large number of observation. It is not easy to handle the data in the form of better way to express the figure is shown in table. So, through frequency distribution we can easily gather the data, and this is given in this slide how we are distributing the frequency or distribution of the different age group, and that age group is related with the 20, 21, 22, 23, 24, 25. So, these are the different age group and their frequency is considered. Next is a bar called a tally bar. Mark is put against the number when it is occurred. After putting this marks, 4 item against the value and the crossing tally is put as the 4 tails with the 5th mark is known as in the above table, and from the 6 marks onward we started a phrase a similar manner. This technique facilitates the easy continuing of the tally marks at the end the presentation of the data. So here the frequency distribution. A frequency distribution refers to the data which are classified on the basis of some variable that can be measured, such as age of the children, etc. So our variables refers to the characteristics that varies in magnitude. In a frequency distribution, it may be either discrete or continuous. So we can say that the frequency distribution might be a discrete or the continuous frequency distribution. A discrete variable is that which generally take integral values. For example, the number of students, the number of books is a continuous variable, can take a integer or the fractional value within the range of the possibility, such as the height and weight of the individuals. So generally frequency distribution speak continuous data are obtained through measurement, while discrete data are divided by continuity. A series described by the continuous variable is called continuous series, or similarly the series represented by the discrete variable is called a discrete series. So there is the continuous variable relate with the continuous series and discrete variable relate with the discrete series. According to the nature of the variables, the frequency distribution may be of two types: a discrete frequency distribution or the continuous frequency distribution. Let us discuss them only by one. So discrete frequency distribution, a frequency distribution in which the information is distributed in a different class on the basis of discrete variables is known as discrete frequency distribution. For example, frequency distribution is a number of children in a 20 family is a discrete frequency distribution. So here the example of the discrete frequency distribution of the number of children in a 20 family, or we have seen that the number of children, family 1, there is no children, means the family that do not have a children is a 3 family which have 1 children, that is 4 family they have 2 children, that is 6 family they have a 3 children, that is 4 family, and family they have a 4 children, that is a 3 family. So we have a total family, and the all 20 family have a number of child in a different way. They have, some family have a 0 child, some family have 1 child, some family have 2 child, and some other family have 3 child, and some family have a 4 child. So that is the discrete frequency distribution, a number of child in a 20 family. Next is in the continuous distribution, in which the information is distributed in a different classes on the basis of continuous variable known as in the continuous frequency distribution. There may be some variable which have an integer value as well as the fractional value. So simply if the value is a continuous value or the integral value or the fractional value, that type of distribution is called as in the continuous frequency distribution. But if we cannot use a discrete value, that is called a discrete discrete frequency distribution. Like in the example, continuous frequency distribution given below. Here in a continuous frequency distribution, a height of the 50%. So height, there are in the 3 person, their height is between 120 to 130 centimeter. There is 5 person, their height is between 130 centimeter to 140 centimeter. There is 140 to 150 centimeter height 10 person, 150 centimeter to 160 centimeter height is 14 person, 160 say 117 centimeter 12 person, or 170 to 180 4 person, and 180 to 192 person. So here we can see that the height of the 50 person and the height is a continuous frequency, because we can use a decimal or we can use fractional value. When we are using the fractional value, that is used, or the decimal value, that is a continuous frequency distribution. But when there is a no option to using the fractional value or the decimal value, then that type of distribution is known as a discrete frequency distribution. So this is the difference between continuous frequency distribution and discrete frequency distribution. In discrete frequency distribution, we cannot put value on the basis of fractional or we can a decimal value, but in a continuous frequency distribution we can put value on the basis of fractional or decimal value. So age, we can using a continuous frequency distribution, but number of children we cannot use a continuous frequency distribution. At that situation we are using the discrete frequency distribution. So after discussing the discrete and the continuous frequency distribution, let us discuss the relatives and the cumulative frequency distribution, which are similar important as analysis point of view in the data. So after continuous and discrete, we go for the relative and the cumulative frequency distribution. So here we are, in this slide we are going to discuss the relative frequency distribution. So relative frequency distribution corresponding to a class in the ratio of the frequency, that class to be the total frequency. The corresponding frequency distribution is called relative frequency distribution. If we multiply each relative frequency by 100, we get the percentage frequency corresponding to the class and the corresponding to the frequency distribution, that is called percentage frequency distribution. So relative frequency distribution is also known as percentage frequency distribution. Let us take certain example related with the relative frequency distribution or percentage frequency distribution. So here there is certain example of the frequency distribution of the 50 student in the subject given below. So class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and the frequency is between 0 to 10 is the 6 and 10 to 20 frequency is 10, 20 to 30 frequency is 14, 30 to 40 frequency is 18 and 40 to 50 frequency is 2. So prepare a relative and the percentage frequency distribution. Next we are going to in this slide. The relative or the percentage frequency distribution can be formed as given in the following table. Here there is x is known as in the class interval, and the class interval is 0 to 10 or 10 to 20, 20 to 30, 30 to 40 and the 40 to 50, and their relative frequency is 6, 10, 14, 18 and 2. So total frequency or the total size of the data is 50. So relative frequency is 6 multiply 50 is equal to 0.12. So here we are multiplying or we are getting relative frequency from dividing a frequency with the number of data size. So here for the first class interval there is in the 6 frequency and the data size is 50. So 6 divided 50 is equal to 0.12. So 0.12 means the relative frequency or the percentage frequency is 12 for the class interval of 0 to 10. For the class interval of 10 to 20, that relative frequency is 10 divided 50 means the 20%. So for the second class interval the percentage or relative frequency is 20%. For the third class 20 to 30, 14 divided 50, that is the relative frequency is 0.28 and that is the 28%. So for the third class interval the percentage frequency is 28% and that for the fourth class interval, that is 30 to 40, the relative frequency is 18 divided 50. So that is the 36.36 and the percentage is 36%. So for the fourth class interval relative frequency is 36% and the last class interval, that is the 40 to 50 and the frequency value is 2. So 2 divided 50, that is 0.04 means the relative or percentage frequency is 4%. So by this we are dividing 100% into the different relative frequency for the different class interval. So here for the first class interval 0 to 10, the percentage is 12%. For the second class interval, that is 10 to 20, percentage is 20%. For the third class interval, that is 28% relative frequency or the percentage frequency, and for the last class, that is 40 to 50, the relative frequency or percentage frequency is 4. Next is the cumulative frequency distribution. So cumulative frequency distribution, in a cumulative frequency distribution, just we are adding the frequency. So cumulative frequency distribution of a class of the total of all frequency up to and including that classes. The cumulative frequency distribution is a frequency distribution which shows the observation less than or more than a specific value of the variable. So here we are showing the less than and more than situation. We are using cumulative frequency distribution. So the number of observation less than the upper class limit of the given class is called less than the cumulative frequency, and the corresponding cumulative frequency distribution is called as in the less cumulative frequency distribution. So by example we can go through in a very proper manner the cumulative frequency distribution here in this slide. Similarly, the number of observation corresponding to the value of more than the lower class limit of a given class is called more than cumulative frequency, and the corresponding cumulative frequency distribution is called more than cumulative frequency distribution. Following is an example wherein the less or the more than cumulative frequency distribution had been obtained. So example, for the following frequency distribution, marks of the 50 student in a subject from both type of cumulative frequency distribution. So first class interval, first we are going to the class interval 0 to 10 is the first class interval, second class is 10 to 20, third is a 20 to 30, fourth is a 30 to 40, and the fifth class interval is 40 to 50, and their corresponding frequency for the first class interval frequency is 7, and the second class the frequency is 11, for the third class frequency is 15, and for the fourth class frequency is 12, and for the fifth class frequency is 5. So here the class interval and frequency is given, and now we are going to understand the cumulative frequency. So here in this table we can better understand the concept of the cumulative frequency distribution. So we can go through this table. So given frequency distribution, so first we are going through the class interval 0 to 10 and 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and their corresponding frequency is given. So less than the frequency or cumulative frequency distribution and more than the cumulative frequency distribution. So marks less than 10, the frequency is 7, marks less than 20, the frequency is 8, 7 plus 11, the cumulative frequency is 10, marks less than 20, the cumulative frequency is 18. So marks less than 30, we are also adding 15. So cumulative frequency is 33, and marks less than 40, the cumulative frequency is 45, and marks less than 50, the cumulative frequency is 50. So by this way we can add on a cumulative frequency distribution. On the other hand, we are just splitting that concept of the cumulative frequency distribution. Marks more than 50, marks more than 0, the cumulative frequency is 50. Marks more than 43, the cumulative frequency is 10. Marks more than 20, the cumulative frequency is 32. Marks more than 30, the cumulative frequency is 7, and marks more than 40, the cumulative frequency is 4. So by this way we can use cumulative frequency in less than cumulative frequency distribution or more than the cumulative frequency distribution. So in more than cumulative frequency distribution, just we are subtracting the cumulative frequency of the final number or the total number of the data size, and less than cumulative frequency distribution, just we are adding the cumulative frequency as much as we are going for the lesser than homogeneous group or the subgroup. In classification, according to class interval, the observations are arranged systematically into a number of group called classes. So such classes is most popular in practices, but the become a discussion we have to define some term which will be used in the above classification. So according to the class interval, we make understanding of the class interval or classification with the class interval. So first, class limits. So class limits are the lowest and the class highest value of the class. So class limit stand with the two part, one is the lowest value of that class and second part is the highest value of that class. So let us take the class 10 to 20. So in 10 to 20, the lowest value of the class is 10 and the highest value of the class is 20. So the two boundary of the class are known as in the lowest level or limit or the upper level or the limit of the class. The lower limit of the class is the value below which cannot be any value in the class, and the upper limit of the class is the value above which no value can belongs to that class. So every class, simply we can say that class limit, there is in the range of the value and there is certain upper limits of the class and the lower limit of class, and between the upper and lower limit there is in the range. So that is called class limits, and that range is called as the class limits. So 10 to 20, that is the class limit, and in 10 to 20 the lower level is 10 and the upper level is the class interval of the class is the difference between the upper class limit and the lower class limit. For example, in the class 10 to 20, the class interval is 10, that is 20 minus 10. This is valid in the case of exclusive method discussion in this subsection later on. If the inclusive frequency distribution discussed later on this subsection, given that first it is covered to exclusive form and then the class interval is calculated. This size of class interval is determined by number of classes and total range of the data. So we first go through the range of the data. The range of the data may be defined as a difference between the lower and the upper limits of the class. So the lower limits and the upper limit, there is in the limit of the class, and that distance between the lower limit and upper limit, that is the number of observation to be popularly classified from below these classes in the given frequency distribution. The frequency of the class is 12, which implies that there are 12 persons having age between 10 to 20. If we add together the frequency of the individual class, obtained total frequency. So here in this class frequency, the table is given the frequency distribution of the 50% having the age of 0 to 50, and their classes is different. From 0 to 10 there is then the 8 frequency, from 10 to 20 12 frequency, from 20 to 30 15 frequency, and from 30 to 40 10 frequency, and 40 to 50 5 frequency. So total size of the data is 50, and different classes have a different frequencies, and that is given in this slide. So here the class mid value. So calculating the class mid value, it is the value lying half away between the lower and the upper limits of the class interval. So midpoint or the mid value of the class is defined as follows. So how we are calculating mid value? So mid value of the class equal to upper limit plus lower limit divided 2. So if the class interval is 10 to 20, so upper limit is 20 and lower limit is 10. So 10 plus 20 is 30, divided 2 equal to 50. So mid value is 15 for the class interval of 10 to 20. So for the purpose of further calculation of statistical analysis, the mid value of the each class is taken to represent that class. Now we are in position to discuss the two methods of classification according to class interval, namely exclusive method or second inclusive method. Let us discuss two methods. So for the calculation of mid value, we are using the exclusive method and the inclusive method. So that method is given in another slide. The exclusive methods, under this method the class interval in such that each upper class's limit is excluded from the class interval. Here in this method the class interval are so fixed that upper limits of one class is the lower limit of the next class. So this is the following example of, there is a 24 student who have secure the marks between 0 to 50. The number who secure 20 marks would be included in the 20 to 30, not in the 10 to 20. This method is widely followed in the practice. So in a exclusive, simply if we are calling the exclusive class interval, so exclusive class interval, so upper limit of a one class consider as in the lower limit of the another class. So if we are talking about the class interval of 10 to 20 and 20 to 30, so in 10 to 20 the upper limit of first class interval is 20, but in 20 to 30, 20 become now a lower limit of another class interval. But if the marks obtained 20 numbers by any student, so which class we mention that marks, we can try to make understanding regarding the class interval for the exclusive method. So simply again I am repeating that there is in the class interval of 10 to 20 and 20 to 30. So in exclusive method of the class interval, so the upper limit of first class interval become a lower limit of second class interval. But if the marks obtained by the by a student is that marks is 20 number, so which class interval we are putting that marks, 10 to 20 or 20 to 30. So it is better if the exclusive class interval method, then we are putting the 20 marks in a second class interval, not in a first class interval. So example given here in this slide, The 24 students appear in an entrance test which all questions are objective type with 25% minus negative marks, and obtained the 50 marks as are follows. So, there is the marks obtained by the different student, that is the 17, 16, 7, 30, 21, 42, 44, 36, 22, 22, 25, 31, 31, 34, 30, 36, 35, 30, 45, 25, 15, 20, 42, 40, 50. Prepare a frequency distribution by using the exclusive method. So, here there is a example given in the slide, that there is the marks of the 50 students, and we have to prepare the frequency distribution by using the exclusive method. So, how we are using this exclusive method? 0 to 10, second is 10 to 20, third is 20 to 30, fourth is 30 to 40, and fifth is 40 to 50. So, in an exclusive class interval method, we are understanding the tally bar is for the first class interval 0 to 10 is 1, second class interval is 10 to 20 is the 3, and the third class interval 20 to 30 is 6, and the fourth class interval 30 to 40 is 9, and the last or the fifth class interval 40 to 50 is 5. So, there are different classes with their different frequency of that class interval. So, again we are going for to understand the inclusive method. So, last one is the exclusive method, and the present slide is related with the inclusive method. In inclusive method, we are using classes upper limits for one class, and that upper limit is not considered as the lower limit for the other class. We are using increasing the one number for the another class. So, in a inclusive class interval method, so 0 to 9 or 10 to 19 or 20 to 29, 30 to 39, 40 to 49 in a inclusive class method. Or tally bar is given in this for the first class interval 0 to 9 1, 10 to 19 3, 20 to 29 6, 30 to 39 9, and 40 to 49 5. So, the different class interval for the different frequency given in this slide in the inclusive method of the mid value calculations. Next is, that means if the data is classified in such a way that the lower as well as the upper class limit are included in the same class interval, it is called inclusive class interval. So, in an inclusive class interval, we can get the data of lower limit to upper limit, but in exclusive class interval we are not getting data of the upper limit. We are transferring data of upper limit into the next class interval. For converting data from inclusive from the exclusive, first of all we find that half of the difference of the lower limit of the class and the upper limit of the processing class or the preceding class. This value is then subtracted from the lower limit of each class and added to the upper limit of the each class. In the above example, this can be easily understand that to understand 10 to 9 divided 2 is equal to 0.5. So, the class interval are 0.5 or 0.9.5 or 0.9.5 to 19.5 or 0.39.5 to 49.5. It also observed that the data is positive, then the lower limit of the first class can be taken 0, and therefore the case the class interval are 0 to 9.5, and 9.5 to 19.5 or 39.5 to 49.5. So by this manner we can also using a class interval in a inclusive class interval method. So class mid value remarks, lower limit of class interval is always included in the class is both in the method discussion above or the exclusive method upper limit of the class is not included in the class. That is why the name is exclusive method, and in inclusive method upper limits of the class is also included in the class. That is why it is called inclusive method. So simply we can say that, so why exclusive method and why inclusive method? In a exclusive method we are not using the upper limit value, that why that is called exclusive method means we are just excluding the upper limits. But in a inclusive method we are using the lower upper limit of the class. So that means we are including the upper limit of the class. That is the reason we are using the term exclusive method and inclusive method. So in exclusive method we are excluding the upper limit, and in inclusive method we are adding the low upper limit. So that is why we are called exclusive method and inclusive method. Principle of classifications. It is difficult to formulate any hard and the fast rule for classification of the data. However, the following general classification may be considered to ensure the meaningful classification of data. So whole data should be properly divided into number of classes between 5 to 15. However, there is no rigid about it. The class can be more than 15 depending upon the total number of observation and variables between them and detailed requirement of the given data, but they should not be less than 5, because that case the classification may not reveal the essential. To determine the appropriate number of classes, that is using by the K, the following formula suggested by Sturgis. So K is 1 plus 3.322 log n, where K the approximate number of the classes, in the total number of observation, log is the nature of logarithm. However, the appropriate number of the class can be taken for a given data depend upon the personal judgment and the other considerations such as range of the data, total number of observation, etc. So by principle of classification we can understand that how we are classifying the data. So one should avoid a odd number of class interval as far as possible, that is 3, 7, 11, 26, 39, etc. One should prefer 5 to 10 or the multiple of the 5 or 10 as in the class intervals such as 5, 10, 25, 100, etc., because the human mind is accustomed more to think in terms of certain number of 5 to or 10. The lower class interval of the first class of the frequency distribution should either be 0 or 5 or the multiple of the 5. For example, if the lowest value of the data is 26, we have taken a class interval of 5, then the first class should be 25 to 30 and instead of 26 to 31. So simply we are using 0 or 5. This is the principle of class interval, even if the data is in an odd number or data in even number. So suppose that if you have a 27 number, and for this 27 number you are not using the 27 to 32. So at that condition you are using 25 to 30. or if data is 43, so class interval is considered in the interval if 5, then the first class interval should be 40 to 45. Slide. The minimum continuity and get the correct class interval, we should adopt exclusive method of the classification. However, where the inclusive method has been adopted, it is necessary to make an adjustment of the determine the correct class interval and to maintain the continuity. However, the adjustment is made when the data are given by inclusive method explanation. The same adjustment has been done in the frequency distribution. So, simply we can say that in a frequency distribution we are using exclusive method of data, inclusive method of data, we are using term on a 5 basis or 0 basis, and always we are using a number that might be 0 to 5 or 5 to 25, 25 to 30, 35 to 45. So, by this way we can using our classification. So, principle of classification there is in the example given in the next slide, and here is the frequency distribution of the 24 by the inclusive method, and in inclusive method that is started with the 0.5 to 9.5. So, number of student is 1 and 9.5 to 19.5 number of student is 3, 19.5 to 29.5 number of student is 6, or the 29.5 to 39.5 number of student is 9, and 39.5 to 49.5 number of student is 5. So, out of 24 students there are different student have a different class interval. The interval of all classes should be the same size, because if the class interval are not of the same width, it is difficult to make meaningful comparison between the class. Sometimes the data may require the inclusive of so many class interval that the frequency distribution is become a large. Then the classification may be done as follows: below 10 or 10 to 20 or 20 to 30 or 30 to 40 or above 40. So, this class is called open end class, and the distribution is known as open end frequency distribution. It may be noted that the frequency distribution, like other type of data preparation, are always constructed to serve some specific purpose, and the technique requirement outlined above must be supplied by the sound subjective judgment it proper frequency distribution to be formed. So, after learning so much about the classification of the data, we have got realized that importance of the classification. So, before move to the next section, let us just highlight and outline some of the main point related with the importance of the classification. So, there are some point here mentioned in this slide, that is importance of the classification. First, it is preliminary to further statistical analysis. So, classification is very primary thing for the further statistical analysis. Second is it facilitate comparison and make conclusion easy. So, classification is also providing you a comparison and conclusion easy or better understanding regarding the data, and it facilitate of tabulation. So, classification is also required to convert data in the tabulation format. So, now we can try to following exercise. Tabulation of data. One of the simplest and the most revealing device for the summarizing and presenting data into the meaningful arrangement in the statistical table. So, simply the tabulation of data is the very simple or very easy to understand and to very easy to present data into a systematic manner, that is called tabulation. So, tabulation is the arranging a data in the meaningful manner and to make it easy to understand and classify data into by the different characteristics. We are using tabulation. We can also define a statistical table as in the logical listing of quantitative data in a column and row of a number with a sufficient explanatory statement. The statement may be given in the form of title, headings, notes to make clear in a full meaning of the data and their origin. In other words, a table is systematically arranged in a statistical data in a column or row. Row are horizontal arrangement, whereas in the column are a vertical arrangement. So, in a tabulation format, we are putting the data in a raw column or in a row and in a column. So, raw is putting data on a horizontal manner and column is putting data on a vertical manner. A table can shown for the purpose of the presentation and facilitating the comparison. The simplification result from a clear cut or the systematic arrangement and which enable the readers to quickly understand, locate and describe the information, comparison and facilitating by bringing relative item in the information in a close together. So, simply we can say that tabulation of a data into a Excel sheet or into a table. So, there first we divided data into the column or into the row. So, row is a horizontal arrangement and column is a vertical arrangement. First thing is that by putting data or by putting data in a table or tabulating data in a table, it is very easy to understand whole information by one site, and it is also easy to arrange data and understand the data in a very simple manner. So, tabulation of the data into a tabulation form or in an Excel sheet, it is a very scientific way to understand the data. It is very easy or it is very meaningful way to understand the data or systemize the data. So, component of the table. Here in this slide we are going through the component of the table. The various component of the table may vary case to case depending upon the given table, but the good table must contain at least following characters. So, if we are talking about the component of the table, that component of the table depend upon the purpose and objective, for which purpose and for which objective we are preparing the data. But in a very common format, there are a certain characteristics and component of table is given in this slide. First is the table number, second is the table heading, third is in the caption, fourth is the stub, fifth is the body of the table, sixth is the head note and 7 is in the footnote. So, these are 7 minimum factors required for a good table, or these 7 content required for the good table. So, at least every table have requirement of these certain contents. So, first go through the table number. So, a statistical table should be numbered. There are different way with regard to the place where the table number is to be given. The table number may be shown either in the center of the top above the title or the left of the hand side of the table at the top. So, always we are putting table number on the top of the table. It might be the center of the table or it might be the left side of the table, but table number is always putting on the top of the table. When there are the many column, it is describe the number each column so that easy to refers it in very possible manner also, or easy to understand. So table number is very important aspect to understand, memorize and finding any information. So table number also giving you a unique point or unique name or unique value for the table. Next is on the table headings. A good table should have a suitable heading. The heading in a brief describe the contents of the table. It should be placed above the table. It should answer the following question. So simply table number is also after the table number there should requirement of the heading of the table, and heading of the table is also put on the top of the table. It might be started with the center point of the document or might be with the started with the left point of the document number after the table number. We are using the heading of the table. So in other words, the heading of the table should be clear, brief or self-explanatory. So what should be, we are putting words for the heading of the table. It should be clear, it should be brief or it should be self-explanatory. So whatever any readers reading that table, the heading is meaningful for their readers or they easy to understand the readers. So simply we are putting clear, brief and self-explanatory heading of any table, but sometime long title may have to be used for the sake of the clarity. Always we are using a short title for the table heading, but sometime it is required for the clarification of the table long title. So we cannot avoid to long title of the table, but whatever we are putting short title or long title, but the clarity is for your readers. Reader have a self understanding clarity. There is no support requirement for any reader for understanding the heading of that table. Next is caption. Caption refers to the column heading and the explanation what information column person. It may consist of one or more column heading, that is under the column heading there may be two more subheadings. The captions should be clearly defined and placed at the middle of the column. If the different column are expressed in a different unit, the unit should be specified along with the caption. So caption also refer to the column heading and explain the information column presented. So simply we also call that, and the caption is then the third important element of the table, and when we are preparing the table we cannot avoid the importance of caption, and the caption should be clearly defined, placed at the middle of the column, and if the different column are expressed in a different unit, sometime we are expressing different column in a different units, which should be using the caption, and caption if you are using the caption, that is also memorizing you in a very frequent basis when you are clicking the caption option. Next is stub. The stub are row heading. They are placed at the extreme left of the table or the perform the same function of the horizontal manner or the horizontal row in the table of the caption do for the vertical column. So stub are the row heading and caption are the vertical headings. So when you are understanding, and there is no requirement of misunderstanding regarding the caption and the stub. So simply stub are the row heading and the caption are a column heading. So they are placed in the extreme left of the table and perform the same function of the horizontal row in the table as the caption do for the vertical column. So next is on the body of the table. So in the body of the table is a central part of the table that contain a numerical information presented in the table. So that must be the vital part of the table. So simply as per the name of the body of the table, so vital part of the table, that is called body of the table, and from the body of the table we get a vital information regarding the data or regarding anything related with the table. So body is considered as the most important part. So when we are designing the table, so we have to give a greater focus on a body of the table. That body of the table is really meaningful, and there are nothing happening in designing the body of the table. So the next point is on the head notes. So head notes notes is on the brief explanatory data applying for all and major part of the material presented in the table, and is placed below in the title, entered and enclosed in the bracket. It used to explain a certain points related to the whole table which have not been included in the title nor in the caption of the table. For example, if the title is measured is frequency written as in the head note, such as in thousand or the million tons or in crores. So the last point of the table, that is known as the footnote, applying the table which is readers support to find the difference understanding should be explained in the footnote. So what should be differences, what should be symbol, we can elaborate that is in the footnotes, and footnotes may be placed directly below the body of the table, and the footnotes are generally used in the following purpose: any special circumstances affected the data, for example strikes, fire, etc., or to clarify anything in the table. So in case of the secondary data, if any information in the table obtained from the some journal or its name or date of the publication or the page number or the table number, each etc. should be mentioned, so that if the user wish to check the data from the original source, verifying the data, the footnote is very important part, and we are giving a whole information regarding the data. So footnote giving you a lot of brief regarding your data or your table. Sometime that brief related with if you are using data from some other sources, or you are using data of the secondary sources data, and that condition if you are not mentioning the footnote of that data, that should not be authentic, or that should not be ethical thing to mention that type of data. So if you are using some others information data or some other source data, you also give that information of from which source you are gathering that table or that data. So footnote is important part for the table, and that is understood as in the last part of